10 meters down, the river is black. Divers descend into the tannin-dark water of the oscilla, their torch beams cutting narrow tunnels through the murk. This is the Page-Ladson sinkhole, a flooded limestone pit in northern Florida. At the bottom, in near-zero visibility, archaeologists work with gloved hands, mapping a place they cannot fully see. The sediment at the bottom of the sinkhole tells its own story. It is dark, fine-grained, and completely starved of oxygen. The technical term is anoxic, meaning there is no free oxygen dissolved in the water between the silt grains. That single fact changes everything about what survives here. In most archaeological sites, oxygen fuels the microbes that break down organic matter. Wood rots, bone crumbles, plant fibers vanish within seasons. But in an anoxic environment, those decomposers cannot function. Decay slows almost to a halt. The same chemistry that preserves ancient shipwrecks at the bottom of the Black Sea work in this Florida riverbed. For the researchers hovering in the murk with dive torches, the payoff is immediate. They find fragments of wood from trees that grew at the edge of the sinkhole, still recognizable after 14,000 years. Remains, seeds, leaves, twigs, lie flattened in the sediment as if pressed into the pages of a book. Bone, the prize, emerges from the silt with its surface detail intact. A mastodon tusk pulled from this layer still carries the fine parallel lines of stone tools. Without the anoxic seal, that tusk would have been a crumbling shadow, gone, along with any story it might hold. It is a rare trick of preservation that makes Page-Ladson an outlier in American archaeology. The same conditions that make excavation so difficult, the darkness, the depth, the tannin-stained water, are what locked the evidence in place and kept it whole. But the evidence that survives is not merely environmental. It includes a mastodon tusk, recovered from the anoxic sediment. Along its surface runs a series of straight, parallel cut marks, natural processes, like the gnawing of other animals or the tusk scraping against rocks, tend to produce random, jagged, or curved grooves. These marks are different. They are uniform and linear, consistent with the repetitive motion of a stone tool held in a human hand. Furthermore, same distinct layer of earth, researchers recovered stone flakes and a biface, a type of shaped cutting tool. The combination is telling: a butchered animal and the very tools that could have done the work. This points decisively to human activity. It is a signature of survival, a record of people processing a massive creature for its meat, marrow, or perhaps its ivory, over 14,000 years ago. That over 14,000-year figure is not a guess. It comes from radiocarbon dating, a method that measures the steady decay of radioactive carbon atoms trapped inside organic remains after death. When something stops exchanging carbon with the world, the atomic clock starts ticking, and by measuring how much of the original radiocarbon has decayed, researchers can read the time. The clock was applied directly to the cut mastodon tusk at Page-Ladson. Multiple samples from the tusk returned an age of roughly 14,550 calendar years before present. Seeds and twigs from the same dark sediment layer gave matching dates. The deposit had not been scrambled. The tusk, the stone flakes, and the biface all sat together in a sealed, anoxic context, with little to no younger material mixed in. That number, 14,550, squarely in a territory that, for decades, many archaeologists believed was empty. Clovis culture, with its distinctive fluted spear points, had long been considered the first widespread human presence in the Americas. The oldest well-accepted Clovis sites fall around 13,000 years ago. Page-Ladson sits roughly 1,500 years earlier, a gap that is not trivial. It is longer than the entire span of the Roman Empire. That gap overturns a long-standing model. It means people were butchering a mastodon beside a Florida river before the corridor between the great ice sheets had fully opened. Something had to have brought them there earlier, and faster. The date does not just add pages to the story, it inserts a whole new chapter. With the clear-cut marks on that tusk, the radiocarbon result turns a single, waterlogged sinkhole one of the strongest pre-Clovis candidates in the Americas. Yet such a claim was not always accepted. Decades ago, when this site was first investigated, its early reports of a pre-Clovis presence were met with widespread and reasonable skepticism. Critics raised serious methodological concerns. They argued that the underwater context was inherently problematic. River currents, they suggested, could have moved artifacts between geological layers, making stratigraphy, the sequence of deposits that tells the story of time, unreliable. The cut marks on the mastodon tusk could be ambiguous, possibly the result of natural abrasion against rocks, other bones rather than human tools. These were not dismissals born of stubbornness, but of rigorous scientific caution. The extraordinary claim required extraordinary proof, and for many, the evidence from this dark, flooded hole simply wasn't solid enough yet. The burden of proof remained squarely with the site. So a new generation of archaeologists returned to the Oscilla, to meet that burden with a level of precision the earlier work could not achieve. They laid a rigid underwater grid across the sinkhole floor, mapping every stone and bone by torchlight, and recording each find with detailed photography. The goal was to build a forensic record of position and depth that could be tested later against the sediment itself. To secure the date, they took multiple radiocarbon samples from different materials in the same layer. A seed, a piece of wood, and the mastodon tusk all returned ages that clustered roughly around 14,500 years ago. When separate organic items from a single horizon produce the same date, the odds that currents mix them from different time periods drop sharply. The crucial test, however, was sediment analysis. In a river current, moving water sorts particles by size and weight, fine detail. The team extracted thin, undisturbed sections of the deposit and examined them under a microscope. No cross-bedding, no sand lenses, no chaotic grain sizes. According to geological context from similar sinkholes, the sediment appears to have been a sequence of fine, organic-rich mud, delicate laminations, likely laid down in still, anoxic water, and never reworked. Tusk and stone flakes sat within this undisturbed layer, not at a boundary where they might have washed in. That single observation changed the argument. The site was not a jumble of redeposited bones and tools. It was a sealed moment in time, a butchery event preserved in the quiet dark of a deep river hole. Extraordinary proof had finally arrived. But Page-Ladson does not stand alone. Decades since those early dives, a mosaic of sites has emerged, each adding a piece to a picture that no longer begins with Clovis. Excavations at Monte Verde in southern Chile reportedly uncovered wooden hut foundations, hearths, and mastodon bones dating to around 14,500 years ago, a site now widely accepted by archaeologists as pre-Clovis. Farther north, at Paisley Caves in Oregon, human coprolites, preserved feces, yielded radiocarbon ages of about 14,300 years, alongside stone tools. In Texas, the Buttermilk Creek complex pushed the timeline deeper still, with stone artifacts lying beneath a Clovis layer dated to around 15,500 years ago. And at Meadowcroft Rock Shelter in Pennsylvania, charcoal and plant remains hint at human presence, possibly as early as 16,000 years, though those dates remain hotly debated. Some researchers note that these sites do not all agree neatly on chronology and signatures. Some are older, some younger. Some rest on unambiguous artifacts, others more fragile traces, a scatter of seeds, a few stone flakes, a cut-marked bone. The acceptance varies. Monte Verde is now textbook fact. Meadowcroft still draws quiet skepticism from researchers who question whether ancient carbon could have contaminated the samples. What connects them is a shared implication. We're here, across both continents, well before the Clovis horizon. The evidence is growing, but it is not yet uniform. It is a puzzle, assembled from fragments, many of them pulled from dark water or deep cave floors, demanding a high burden of proof. Page-Ladson, with its butchered mastodon and sealed anoxic layer, It is often described as one of the more compelling pieces of evidence yet found. And yet even this site has a silence at its center. No human bone, no tooth, no fragment of DNA has come from Page-Ladson. The evidence is entirely in the marks on a tusk, the flakes of stone, marks that read as butchery. It tells us people were here, processing a carcass. It tells us roughly when, but it cannot tell us who they were. We see the work of their hands, not their faces. We cannot trace their ancestry, their physical appearance, or the route their forebears took. In archaeology, a stone tool is a kind of signature, but it signs no name. That anonymity points to the deeper difficulty. During the last glacial period, people first moved into the Americas. Sea levels were far lower. In some places, over 100 meters lower. The coastlines they would have walked, the campsites they would have left behind, now lie under tens of meters of ocean. This is not a theory. It is a measured geological fact. The submerged continental shelf off Florida's Gulf Coast extends for miles. Drowned landscape of ancient river channels and sinkholes. Sites like Page-Ladson survive because they were inland, in a river channel now far from the open sea. Many scientists suspect that the earliest coastal sites, which might hold the oldest evidence and the most direct clues about routes and timing, are almost entirely out of reach. That is the honest problem. Underwater archaeology is painstaking and expensive. Visibility is measured in centimeters. Currents rework sediments in ways we are still learning to read, and the places most likely to hold answers are often among the hardest to probe. Page-Ladson is precious because it is rare, a deeply buried, sealed sinkhole in a shallow river, accessible only by dive teams working in what feels like liquid night. It gives us a foothold, but it does not resolve the larger story. The pre-Clovis record remains a mosaic of such sites, each fragmentary, each advancing the timeline in fits and starts. Now, the individuals who left those cut marks remain behind a curtain of dark water, holding their silence.